Hello everyone, it's Mrs. Suderman. Let's find the quadratic functions in different situations. So this is the guided practice side of the worksheet that you can print off of the website, or you can just wait till you get it in class, but you definitely should take notes because we're covering a lot of different things in this video. Okay, so number 1 and 2, determine whether each data set could represent a quadratic function and explain. So because of quadratic functions having a certain pattern to them, and you'll see in just a moment, to determine if a data set represents a quadratic function, there's two things that you should check. First is that the x values are equally spaced. So they must all be 1 apart or 2 apart or so on. And then the y values, their second differences must be constant. So let's go ahead and look at number 1 so you can see an example of that. Okay, so if we're looking at the x values on number 1, going from here to here, it went up 1. Here to here, it went up 1. 1 to 2, it went up 1. 2 to 3, it went up 1. So the x values are equally spaced. So that's good. So that's the first thing we needed to check. And then now we're going to look at the y values. We need to look at the second differences. But before we can get to the second differences, we need to look at the first differences first. So going from 35 to 22, 35 minus 22, we've gone down, well, from 35 to 22, we've subtracted 13. From 22 to 11, we've subtracted 11. From 11 to 2, we've subtracted 9. And then from 2 to negative 5, we've subtracted 7. So those are the first differences. And you'll notice those are non-constant. So the second difference is, so from 13 to 11, we've added 2. From negative 11 to negative 9, we've added 2. From negative 9 to negative 7, we've added 2. Those are constant. Therefore, number 1 here, this data is quadratic. On number 2, we're going to check the same thing. So first check to make sure the x's are equally spaced. So from negative 2 to 0, we've added 2. From 0 to 2, we've added 2. 2 to 4, 2. 4 to 6, 2. So those are equally spaced. Now let's look at the first differences. So from 18 to 10, we subtracted 8. So 10 to 6, we subtracted 4. 6 to 2, we've subtracted 4. And then from 2 to 1, we've subtracted 1. So those are the first differences. So then the second difference is, from negative 8 to 4, we added 4. From negative 4 to negative 4, that didn't change at all, so that's 0. And from negative 4 to negative 1, we added 3. Those are not constant, so therefore this is not quadratic because the second differences are non-constant. Okay, now number 3 and 4 require a lot of organization, so make sure you've got some space to write down. So I'm going to move the page down a little bit here. Okay, so on number 3, we're going to write a quadratic equation that fits each set of points using a system of equations. So for these, I'm going to use a table just because it helps to organize things a little bit better. So I'm going to put my x and y in the first column. In the next column, I will have f of x equals ax squared plus bx plus c. And then in my third column will be my system of equations. Okay, so I'm just going to list the points I have over here. So I have 0, negative 8, 2, 0, and negative 3, negative 5. These are each x and y values. So I'm going to plug those in to the x and the y, or the f of x, here in the second column. So I have negative 8 equals a times 0 squared plus b times 0 plus c. So the a times 0 is just cancels. B times 0 is still 0. So over here I have C equals negative 8. So that's just that simplified. Next line, same thing. So I'll have 0 equals a times 2 squared plus b times 2 plus c. That simplifies 2. So 2 squared is 4, so I have 4a plus 2b plus c equals 0. And then finally, I will have, oh, there is supposed to be a negative right there, -3, -5. So I have -5 equals a times -3 squared plus b times -3 plus c. So -3 squared is 9, so I have 9a minus 3b plus c equals -5. So now I will use this system of equations, and let's just type them into the calculator. Okay, so here we are in the calculator. I'm just in a scratch pad. I'm going to go to solve a system of linear equations. I'm going to go to Menu, Algebra, Solve System of Linear Equations. I have 3 variables. Whoops. Let's go back to 3 variables. And I'm going to rename them to be A, B, and C, since those are the letters that I was using. So A, comma, B, comma, C. All right, so I've got C, what's going on here, equals -8. I have 4a plus 2b plus c equals 0. And finally, I've got 9a minus 3b plus c equals -5. So those were the equations that we had in our table. We hit enter, and so we get 1, 2, and -8. Those are the values for A, B, and C. Those are not the solutions for the for x and y. We already know what the points x and y are. But remember, we had ax squared plus bx plus c. So that's A, B, and C. So let's switch back over to our worksheet. Okay, so since A was 1, B was 2, and C was -8, the A and the B and the C will fill those back in now. So our equation is f of x equals 1a squared, so x squared, so plus bx, so plus 2x, and then plus c, so minus c. It's because we have a, I'm sorry, minus 8, because we have a -8. So that's our equation. Okay, so let's do this again for the next one. So again, let's make our little table. Okay, so we'll have -1, -16, 2, 5, and 5, 8. So first, I'll have -16 equals a times -1 squared plus b times -1 plus c. Next, I'll have 5 equals a times 2 squared plus b times 2 plus c. And then finally we'll have 8 equals a times 5 squared plus b times 5 plus c. So let's go back and simplify these for the third column. Negative 1 squared is 1, so we'll have 1a, or just a, minus b, negative 1 times b, plus c equals negative 16. Now we'll have 2 squared, so we'll have 4a plus 2b plus c equals 5. And then finally 5 squared is 25, so we'll have 25a plus 5b plus c equals 8. So again, we'll go and type those into the calculator. So we'll go to Menu, Algebra, Solve System of Linear Equations. Again, we'll have 3. Let's use A, B, and C to cut out any of the confusion. Oops. Okay, so we had A minus B plus C equals negative 16. For A plus 2B plus C equals 5. And then 25A plus 5B plus C equals 8. So here we get negative 1, 8, negative 7. So since A was negative 1, B was 8, and C was negative 7, that means f of x equals, so if we have ax squared, so we'll have negative 1 times x squared, so negative x squared. B was 8, so we'll have plus 8x plus C, which was negative 7. So that's our function. Okay, for the next part, write a quadratic equation that fits each set of points using quadratic regression. So this is a lot like linear regression, which we've done in the calculator before. So we'll have the points negative 2, 6, 0, negative 6, and 3, negative 9. So let's go ahead and switch back over to the calculator. Okay, so I'm going to start out by making a new document. No to save. And I'm going to start by adding a list and spreadsheet. So I'm going to label my column X and Y. And they gave us 3 points, which were negative 2, 6. So there's negative 2, 6. We got the point 0, negative 6, so there's 0, negative 6. And finally the point 3, negative 9. So the calculator will do the rest for us. We just have to know how to get it started. So we'll go to Menu, Statistics, Stat Calculations, and we're looking at quadratic regression. So here for the X list, we'll just choose X. For the Y list, we'll choose Y, and then hit OK. So then you see here, it tells us the A, B, and C. So we have 1, negative 4, and negative 6. So since that was 1, negative 4, and negative 6 for the A, B, and the C values, ax squared plus bx plus c. So for number 5, we'll get f of x equals positive x squared minus 4x minus 6. Let's do the same thing here for number 6. So we have the points 1, 4, negative 2, 13, and 0, 3. So again, starting from the home screen, we're going to go to a new document, say no to save, add lists and spreadsheets, label the columns X and Y, so we had the point 1, 4, so there's 1, 4, we had the point negative 2, 13, and finally the point 0, 3. So we've got the values in there. Now we just need to get the equations. So we go to Menu, Statistics, Stat Calculations, and again Quadratic Regression. So for the X list, we'll choose X. For the Y list, we'll choose Y. Hit Enter. So here we get 2 for A, negative 1 for B, and 3 for C. So that means that f of x is 2, which was A, x squared, B was negative 1, so minus x, and C was positive 3, so plus 3. Number 7, the data table shows the energy E of a certain object in joules at a given velocity v in meters per second. Find the quadratic relationship between energy and velocity of the object. So we are given E and v. It says shows the energy at a given velocity v. The given velocity tells us that the velocity is the independent, in other words, the x. So if velocity is x, then energy is y. Now we will fill in the same information in the table in the calculator to figure out what the equation is. And then in the end, it will give you that f of x equals a will be 2, b will be 0, and c will be 0. Therefore, you would get f of x equals 2x squared. But since we're using the e and the v, the energy at any given moment is going to be 2v squared. Part B says, what is the energy of an object with a speed of 5 meters per second? So it asks for the energy, and it gives us a velocity. So we'll have 2 times 5 squared. So that's 2 times 25, which is 50. So you have 50 joules. And what is the velocity of the object if the energy is 128 joules? So if the energy is 128, we need to solve for v, and we can use the square root property on both sides. I'm sorry, that's 2v squared. Our equation was 2x squared. So if we divide both sides by 2, we'll get v squared equals 64. Therefore, the velocity is 8 meters per second.